Okay, hello everyone. So my name is Yu from University of Hannover, so in Germany. And so for this year's MMSat task, so we have concentrated in the following two tasks. So one is the multimodal flood level estimation. So from image we say, okay, if it is the need level flood or not. And also the second is the city centered satellite sequence. So from sequence we say it is the flooding or not. So for the first task we have some kind of rule-based method. So we have a 4-step method. First, we check, okay, if this image is the water relevant or not. So we just based on some global features, okay, created by pre-trained network on ImageNet or Place 365, and we say, okay, this image is flooding or not. And after that, we process the flood-related image with OpenPose and DeepLab V3, so which are trained on AD20 dataset. And after that, what we are expecting to, okay, extract some distance features, because we see that a very good relationship we can represent is the key point of this body to some water lines. So we can just represent the relationship between the people and water. So that's why we also reject some person. For example, so the open post detection bodies are not confirmed by the segmentation, or sometimes the segment is too small. And also we want to keep using the standing person rather than some sitting or lying person. And we create some distance, so we make a slice based on the skeleton and also reject some other boundaries, maybe just on the people's back. And then we just detect the connecting boundary of these two segments. And then we just abstract with a simple horizontal lines to represent the water line. And then we use this distance to represent the relationship. And after that, we combine this distance we created and also with the open post confidence score to do another second level classification of how depth is the water. So this is the basic ideas we do this part. And following other 4 rounds we have created. First is the visual information only. So, and secondly, we use the text information, and we combine the text, use the text CNN and combine with the fast test word embedding. And also we use a very simple way to combine them. So we just, if both of them are predict positive, I will say, okay, the fused model say it is positive. And also in the 4th round, we considered if we can use the old data set to improve our relevance filter. So that's why we use the MMSat 17th data set to improve our relevance filter. So in this case, our result kind of still okay. So maybe 3 or 4th on this task. So let's see some examples. So some success examples. So for every skeleton, I will just make one prediction. This is correct. So most of them have knee level water. And also this is the case with very rare water. And also another case, so people are just mainly in the water. And still we have some failed cases. So such as, okay, we may have open post problem. So open post detect this skeleton on this motorcycle. And also we have this case, okay, segmentation is wrong. So he say, okay, this is a stone. And also we may have some problem about what wrong estimation of the water line because there's a small vehicle just before him. But it works relatively good if it is in front of a car, but maybe this small car is the very problematic. And after that, we have the second task, so satellite sequence. So we think the pre-processing is very important for this task because each channel may have its own characteristics. So that's why we first make a normalization about each channel separately. And then we just use simple way, so minus the mean and divided by the standard deviation. And then we use the RGB channel only, and resize, make it smaller because the computation restrictions. And also we eliminate some of the incomplete images with the organizer provided labels. And after that is our architecture. So we used this. So we first use a DenseNet 1-to-1 to create images features, and then so connect them with LSTM, so temporarily. And at the meantime, we ask for each LSTM cell output one prediction label. And in this case, we may suffer some problems such as, okay, the image sequence are not the same length, so that's why we padded some 0 images and create a mask. And also we use this mask to mask on our loss and metrics to eliminate the influence on that. And also we do the prediction for the sequence if one of the layers are positive. And this is our for round because the organizer provides a flooding label for each layer, so that's why we simply use it for each layer output. And then we also think maybe we can just use the sequence level label provided by organizer. So we just make a repetition of the labels for each layer. And also we in round 3 try just half repeated because we just see, okay, in the flooding labels, they have such a pattern. So we just see, okay, if this pattern matters. And for the last round, we just compare a magnitude 1 LSTM. So we just ask for the whole sequence. We make one prediction. So from the result, we can very significantly see that the many-to-many LSTM makes benefit, and also our round 3 achieve the best result for this task. In summary, so we have provide 2 solutions for both tasks. And what for the flood level estimation, we think so we can improve our waterline extraction, also reject rules, and also we will consider using in the future the panoptic segmentation. And also currently we are using a vertical slice, so which is not that good for rotation. So maybe we hope to improve it. And we also hope to have more data sets related to maybe melty water levels. And for the second task, so we have achieved a very nice result, but however, so the data set and train set is very small. So we don't know if we just learn some elimination changes or seasonal changes. So I'm just consider, so maybe some other sequences from other locations and maybe other time ranges may be provided for a better comparison about these models. So that's my talk. Thank you.